And so a lot of people pick the worst thing they could do.
So I know what lightning is, but at the same time, I don't know what lightning is. So, like, what's happening up there?
There's charge separation that goes on inside a thunderstorm. So, okay, so thunderstorms, you got a lot of precipitation, water, hail, and you have updrafts, and the updrafts will blow up the light cloud particles, and they go up to the top, and the heavy stuff, hail and rain, fall down, and they bump into each other. And it's like walking across a carpet, and you can pick up charge, and the updraft blows the lighter stuff up, which usually charges positive. The heavier stuff falls under its own weight, and that usually charges negative. So you separate the charge, and you start building up more and more charge, and the electric field in between the voltages rise, and it gets big enough where then it sparks.
so what determines where the lightning goes?
I mean, lightning pretty much can go where it wants to. It can carry its own charge and modify the electric fields. And so it's really hard to predict exactly where it's going to go. But generally, it's wanting to follow where the charges are. And actually, lightning doesn't really see the ground until it starts getting pretty close. So normally, there's a layer of charge right above the ground that kind of blankets and makes the ground look featureless from the lightning's point of view. So it has to get pretty close within 100 yards or so before it starts seeing structures like houses and trees and people on the ground. And one thing that determines it is that as it approaches, the charges are so big in the lightning that you start getting all these little sparks off of things on the ground, off of tree branches, off of TV antennas, off of people's heads. And whichever spark races up and catches the lightning, whichever one wins is the one that gets struck.
When we were talking about like lightning coming from the cloud, so to speak, to the ground, that sometimes it seems to like pause. Is that why
Yeah.
sometimes when I see it, it looks kind of like it goes in stages, like it goes to here,
Yeah.
then it jumps, then it goes to there.
Yeah, that zigzaggy lightning pattern is because lightning steps. So lightning propagates in a stepwise manner that's called the stepped leader because it steps, maybe about 10, 20 yards or so each step, and sometimes it can branch. So it'll have this zigzaggy branched appearance. Why does it do that? Actually, we don't know. How does it do that? We don't know.
Is all lightning? Is it all the same, or are there different kinds, different?
Is all lightning the same? Okay, well, there's a couple ways to look at it. So most lightning never leaves the thunderstorm. So most lightning starts inside a thunderstorm and never leaves. Maybe two-thirds of it, three-quarters of it, never leave the storm. That's called intracloud lightning. And so you'll see thunderstorms lighting up and there's a lot of action. And then every once in a while, it'll send one down to the ground. And that's cloud to ground. That's what most people are concerned about when one comes down and can potentially hurt people. And are those two types of lightning, the stuff up there and the stuff that comes down, the same? Yeah, basically, it just went someplace different. Consider heat lightning. So a lot of people think that heat lightning is something different. It looks different. You see the sort of the sky light up, and there doesn't seem to be a thunderstorm. It seems to be something different. But it's actually just lightning from a normal thunderstorm that's far enough away that you can't hear the thunder. Thunder can only go so far. And so there's a lot of different ways we see lightning that we give it different names, but it's actually just the same thing. Now, having said that, there are some types of lightning that do seem to be truly different. There are giant electrical discharges above the thunderstorm. So sometimes lightning can, instead of going down to the ground, can shoot up to space. Those are called gigantic jets. And when you start going up towards space, the air gets, the density of air gets so low that it starts behaving differently, and it turns into these giant blue fans that shoot up to space. And so it starts behaving differently. Other types of electrical discharges are when you have lightning near the ground, you can get these giant red jellyfish above the thunderstorm at the edge of space. Those are called sprites. And those are behaving differently. And there's other types of electrical discharges inside thunderstorms too. There's types that make lots of gamma rays. The thing that made the Incredible Hulk. These are energetic photons, sort of high energy versions of X-rays. And thunderstorms can make those too. And there's some type of electrical discharge inside thunderstorms that can make gamma rays, and that seems to be different as well.
Is the thing about like I always learned like one Mississippi that would tell you how far away it is. Is that true?
That yes, so now that's part of what we call the 30-30 rule. If you can count to 30 and not hear the thunder, then that's by some measure it's probably far enough away. The second part of the 30-30 rule is wait for 30 minutes. But the first part of that 30-30 rule is really dumb actually, because if you can hear thunder at all, it's close enough to hurt you. So you're just giving it an extra 30 seconds to get you by standing outside counting. But actually being near a tree is one of the most dangerous places you can be during a thunderstorm. And so a lot of people pick the worst thing they could do. And the reason is lightning likes to strike tall, pointy things. And so that tree has a reasonable chance of getting struck. And lightning strikes are messy. There are currents flowing everywhere. There's going to be sparks flying off the branches of the tree. There's going to be currents flowing through the ground. And so you're sort of tying your fate to the fate of that tree. And so if you're staying next to the tree, okay, the tree might get struck, but then can send off what's called a side flash and hit you off the branches. The currents that come down the tree will flow across the ground, will go up one leg, down the other. That's called a step voltage. And that can shock you that way. So a lot of people are hurt by taking shelter next to trees. It's not a good idea.